everyone. I'm Ed Kiebler. This is Ryan Thompson. We're at the factory here in Kent, Washington that Rottler manufactures all their equipment from. And we kind of want to introduce Ryan here. He's one of the newer fellas, and he just started a new department called the Applications Engineering Department. Ryan's the head of that. As we get into this high-performance thing and our customers demand more from us and demand more specialty equipment or tooling or what have you, that's going to be Ryan's area of expertise. He's already been a tremendous asset. We are so happy to have him and looking forward to a long tenure here.
Yes, absolutely. Thanks, Ed. Thanks for the introduction. Yeah. I've been here for about 4.5 years now and been doing special projects and research and development here at Rottler, and really excited to start sharing a lot of what I've learned and keep learning with Ed and with our customers. And we'll keep going, and you know, we've been working on a new machine here that we're going to unveil a little bit here and give a teaser, I think, and hopefully you guys like it and enjoy it.
Yeah, so talk a little bit about the machine, Ryan, and what you know, what our customers were kind of asking for, and how we're trying to answer those problems or those demands.
Yeah. So this is the EM45. It's been about a 2-year project now that we've been working on developing, and we went and we looked back at all of the old machines, and I know you were involved in telling us what customers were really attempting and what kind of guys use. And the biggest thing here was coming up with a package that would let you do a pretty large work envelope and have a lot of work, but still keep the footprint small. You know, our other format machines like the 69s, they get really big and the table moves and it takes up a lot of space, kind of hard to fit in your garage. And that floor space is even valuable if you're Rottler or if you're absolute production remanufacturing facility. So
great point.
Having something that you can put on the floor, maybe even put 2 of them in there, and couple that up with another piece of equipment like the hone and be able to get a little work cell going and really increase production and really make sure that it's something that's simple to use and can do just about anything you want to throw at it.
So tell us a little bit about what makes this machine unique, Ryan.
Yeah.
You know, because there's boring bores out there and there's surfacers out there, and of course we have our F69, which is kind of a block machining center. Tell us a little bit about what the unique characteristics are of this EM45.
Yeah, the EM45 is a unique machine, mostly in part because it is a traveling column machine. That's what's going to be different than the 69 series machines. That big work envelope where the bed moves. If you're on an F69, it's a boxed weigh machine. This is a linear railed machine. And then the boring bars, we're used to having that work float, and you use centering fingers, and you can just bore holes. So here on this machine, we're using our probe, and we have the ability to bore and deck. So you can kind of combine the surfacer, either like an S85 or S86, and couple that up with an F10, and that's kind of where we merged together and said, let's do one machine that kind of takes up some of both of those and gets you the flexibility to do either of those operations in something that's, again, that small footprint, large work envelope.
You mentioned linear weighs. Explain to the audience or to our customers what a linear weigh machine brings to the table versus a flat weigh machine.
Yeah, so traditional machines used to all be pretty much boxed weigh machines, which means you had a friction surface that was oiled and it was riding on that. The drawbacks of that system is whereas they're very rigid and very strong, you have to move very slow because you can tear what's called the terside out if you move too fast, and it generates heat, and you end up doing a whole rebuild on your machine. So linear slideways, they came in, you know, we've been doing them for at least probably 10 or 15 years, I think now. And that's a low friction surface, and what it lets you do is it gives you the ability for the machine to move very quickly. And they're low maintenance, they're sealed, so that's a really big benefit. Something on like this machine here, and that's another thing that makes this one unique, is we're trying to go as fast as, you know, we thought was capable for a machine of this footprint. So we've scaled up, and with the linear rails and the ball screws we're using now, we're able to run 500, 600, 700 inches per minute. Whereas on something like a boxed weigh machine like the F69, 150, 200 inches a minute is kind of the limit before you start degrading those surfaces. So this machine is going to be just probably 2, 3, 4 times faster, depending on how it's set up for you, than one of those other boxed weigh machines.
Okay. May not bore any faster.
No, that's a good point. That is a very good point.
But the linear weighs, what we're looking at is the movement in between.
Yes.
You're so much faster on a linear weigh machine versus a box weigh machine. How about accuracy, Ryan? Is a linear weigh machine more accurate than a box weigh machine?
Typically it is, especially on precision, slow speed movements and hand wheel movements. So on a linear rail machine, you have less friction, less stiction as we call it, which is that static friction. On a box weigh machine, you know, it's not uncommon. A guy comes over and he's using his hand wheel and you have to give it 3, 4, 5 clicks before things start to move.
Okay.
On a linear railed machine, there's almost zero backlash. You're on the ball screw and you've got these rails that are just super low friction. So you pretty much touch these things and they're just immediately moving and they're going to move that exact increment.
Okay. Well, do you want to show the audience a little bit about how this machine runs?
Yeah, we'll just
and
show
some of the advantages?
I mean, the cool thing, and it sums it up, is we'll run the probing operation.
Step back out of the way here.
Yeah, we'll just give it a little view here. So we got this set up. I'm going to go ahead and hit start probing here. And she's going to go ahead and take that probe and just touch all these bores.
Now, Ryan, I noticed that the probe rotates a quarter of a turn every time it touches.
That's correct. Yes.
Explain to the audience why that's important.
That's important. So on these probes, these Renishaw probes, that touch surface, by having it index around like that, with the servo motor, if you have any run out in your probe, that's going to basically take up that effect.
Okay.
Whereas if you don't have a machine that's going to index, if that's not dialed in perfectly, then it'll typically lose a little bit of accuracy. So that's why we like to, any of our machines that have a servo motor, we can take advantage of indexing. Now, it's still best to dial in your probe tip and check it every now and again, but they do use, you get some run out in these over 3-4 months usually. So having it indexed, if it's a little bit off, your locations will be okay. The measured diameter will still be a little inaccurate, but for what we care about, it's usually the location.
So, wow, it's finished probing.
Yep, we're done there.
Okay.
We'll move that out.
Yeah, that's having been around the F69 and the old box weigh machine. We'd probably still be on the first bank, quite honestly. Yeah. Okay.
Yeah, we're just about a minute now for a V8.
All right.
So.
That's phenomenal.
Yeah,
that's awesome.
And that's from, like you said, that's the linear rails. That's our higher pitch ball screws we're running now.
Okay.
And that's where this machine's really going to try and stick it in somewhere, take up a little bit of really less space, and you're just fast.
All right.
Really stepping, if you're going from a boring bar and using the centering fingers, and that was one of the good things, is those old boring machines are really fast with the centering fingers.
Right.
And a lot of our customers that have those, and they're, it's quick, the probe, like you said, a lot of our other machines, it's been slower. So we were saying, how could we get a probe machine to go as fast as one of those boring bars? At least get close.
And that brings up a great point, is the old boring machines used 4 fingers that came out and centered. And the accuracy of those isn't anywhere close to what this probe will give you positioning-wise. At least in my opinion, those old 4 fingers, great, fast
and efficient.
Yes, fast and efficient.
If they're not dialed in perfectly, and if they're not ground so that they've been maintained, then this guy will get you under 1,000 every time, just all day long.
Yeah, typical accuracy on one of those was anywhere, if you lapped them in, you could get within 1,000 or 2. Typically it's 3. So we're going to be 3 times more accurate with our positioning on this machine.
All day long under 1,000. I mean, honestly, the thing will probably do a 1/2 for accuracy.
Okay.
But easily under 1,000 if you haven't dialed it in and never checked it. It's worry-free.
All right. Well, folks, that's it from Kent, Washington, here at Rottler's headquarters.
Hey everybody, it's Ryan, the applications engineer at Rottler. I'm down here on the floor at EPE with the brand new EM45. I have a special guest with me today. This is Street Outlaw star Dominator's own daughter, Jolie. You want to introduce yourself?
I'm Jolie, I'm 15, and my dad is Dominator from Street Outlaws.
So you guys brought your own block down here today.
Yeah, we pulled this out of our coupe that we're using for the original street show, and we're just getting some work done on it.
And go ahead and tell, I mean, we've been working together maybe about an hour, hour and a half.
Yeah, we've had about an hour of just going through the crash course of what's going to happen, what we're going to be doing with the motor and all that stuff. So.
And what have we've done, I mean, you came in with no background experience. At least you told me never touched a CNC machine.
I've never even touched a CNC machine. I've never been this close to one, so I started completely from scratch with all of this.
And how has it been? I mean, you picked it up extremely fast.
Oh, yeah.
But we probed the bores, we probed the deck, we've cut this bank. We're going to cut the other bank here in just a moment. How's that process been for you? Has it been pretty fluid?
Well, it's a lot easier than I expected it to be. It's a lot more mechanically inclined rather than me doing it. Yeah. So it's been a lot easier than expected, but it's also a bit more intricate in the whole numbers, axle and axis and all that stuff. So it's not really what I expected.
But we're here.
Oh, yeah.
And I got to give you a lot of credit. So are we ready to fire this thing up?
I think we are.
You want to go ahead and hit cut left there?
All right.
Jolie's already wrote this program. We spent an hour and a half. We're here to run it. So we've already done this side. We'll flip it over and make some chips.
So Ryan, what RPM is this spinning at?
Yeah, so we set that up at the 800 RPM roughing, 20 thou inch per rev feed. We're doing 2 passes here, just a minimum cleanup. The block's pretty straight, so we're just going to take off, I think, a total of 8 thousandths.
Okay.
And yeah, I mean, hopefully it looks good. The other side came out beautiful. Clean this one up, should be just great. And we put it back together tonight and take it home, right?
It's going to be a late night. So here it says rough feed rate. What does that mean?
Yeah, so that's the one we're running right now. We can run that rough feed rate a little bit faster. And just to save time, right? We care about the finish on that last pass. So like what you did earlier, setting a guaranteed finish amount of 3 thousandths and a 15 thou feed rate and at 900 RPM, you know, we're gonna kind of speed through this, and then that last one we can slow down and get the finish that you guys wanted on this.
All right. So how long have you been working with Rottler and CNC?
I've been with Rottler for 4 years. I did a little bit of CNC stuff before that, and yeah, like you asked me earlier, like how often do you do this? And I was like, enough to be dangerous, but probably not as much as some people think. But I won't tell anyone else that. Pretty cool process, though, huh?
Yeah. So is this slower or faster with the finish?
We're faster on the feed and slower on the speed. Slower on the feed and faster on the speed, right?
Yeah.
And we did that. Remember I said, hey, it's just a tip. You can speed up your RPM on the finish stop. So if you were down here or walking around the shop, you kind of hear that spindle speed up, and you say, oh, that's going to the finish pass. And it's just a nice little trick to say, maybe I should get back there and check out what's going on.
Make your way across the shop by the time it's done.
Actually, she's looking pretty good. I think we're going to get a good finish again.
The other side turned out very nice.
It was. Yeah, so while that's finishing up, you know, this is the EM45, boring, decking, automated 3-axis CNC with the 4th axis rollover here, all from Rottler, brand new. Julie, it's been fantastic. Thanks for bringing us up there. It's been great working with you. I'm sure we'll be hanging around, making a few more chips. And with that, back to the studio, and we'll catch you guys later.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.